Good morning, good afternoon. Welcome, everybody. Thank you so much for taking the time out of your busy day to come join us at Corellium on our webinar on reverse engineering deep dive into iOS this time. Last month, we did Android, which was pretty awesome. And this month, we're going to focus on iOS. Now, this is also kind of the concluding set of webinars on app pen testing, at least for a little while. We're going to be switching over to other topics in July, August, and a little bit further. So please keep an eye on that. My name is Brian Robison. I'm Chief Evangelist here at Corellium, and I am joined today by two speakers. We get the specialty of having two speakers. First, I want to welcome our guest speaker from Cyber Consulting, Rob Ferri. Are you there, Rob?
Hello. Hear me?
Yes, we can hear you now. Yeah.
Perfect. Thank you for having me.
Awesome. It is great to have you on, and I really appreciate it. And as we've talked before about our community contribution program that we have at Corellium, where you can write for us, you can also come speak for us on webinars and doing all these kind of fun things. So Rob's going to join us today. And then, as always, we're going to have Stephen Smiley, who's our Corellium researcher focusing in app pen testing. Stephen, good morning, good afternoon.
Good morning, Brian.
Awesome. Welcome aboard. All right. So we're going to go ahead and get started and get moving this morning because we have a lot of really cool content for everybody. A little bit of housekeeping before we get started. Obviously, this is a webinar. Everybody is muted, but please, please, please do engage with us. You've got three speakers on this morning who are going to be able to help answer questions, direct you. Stephen and I are going to be behind the scenes while Rob is speaking and vice versa, looking at questions and asking them and answering them. So please do engage with us using the QA tool in the product. The webinar is being recorded and it will be available shortly on demand after this session is complete. So if there's something that you don't see on the screen, because we are doing a combination of presentation and live demos, there's a possibility that something might be too tiny to see on the screen. We will do our best to explain it, but it's always helpful to be able to go back and review the recording where you can stop it and pause it and zoom in. So please feel free to utilize those recordings. And today, I just want to go over a couple of things just to set the groundwork for what we're going to be talking about today. And we're talking about, doing things like mobile security. And why is mobile security and testing so difficult on mobile devices? Well, if we look at the predominant factors that we're faced with today, basically, we have a problem acquiring devices. Now, this isn't because we just go out and buy brand new devices or we do specific things. These devices are, pretty darn easy to come by. You can go anywhere and pick up a device. The problem is that we need very specific operating systems. And why do we need that? Really, it's because we need an operating system that we can jailbreak or root or do something with it so that we can actually get out of the vendor's walled garden. And that's why mobile security is so much more difficult on mobile devices versus, a traditional Windows box, is because of these walled gardens and sandboxing and encrypted containers and things like that we're not able to readily inspect data at rest and data in motion and things like that we need to do when we are pen testing or when we are doing security research or threat research or any level of security related research on a mobile device. And the final thing that we have is when we're dealing with physical devices, we waste a lot of time. And this time is, from the security research standpoint, this is time wasted in, acquiring a device, getting the right operating system on it, jailbreaking it or rooting it, spending time restoring it and reflashing it up, down, all these kind of things. Maybe you're a global team and you ship devices around the world. All of this time is essentially wasted and takes away from what you are doing, which is your security research. So these three core problems are essentially why Corellium exists. And how we can solve these is because we're a true virtualization platform. So if you think about what you can do on the Windows or Linux side with VMware ESX, we essentially offer the same kind of capabilities, but for ARM-based platforms like iPhones and Android devices. There's also other IoT devices where we do the same level of virtualization for. But just like VMware ESX, we are a type 1 hypervisor. We run on bare metal ARM servers to run ARM-based device OSs. Now, we aren't like VMware. When VMware basically came out, they created one type of device, essentially a generic x86 PC. They didn't model specific models of PC like a Dell Latitude laptop or a specific Lenovo laptop. They didn't model specific devices because essentially they're all generically the same. However, in the IoT world and in the mobile phone world, these devices are very, very, very specific. And if you're going to be doing a test on an iPhone 14 Pro Max, that is a lot different of a device and capability range than an iPhone 7 or something like that. So in our world of virtualization, we actually model the individual devices rather than just a generic device and you can run any version of iOS on it you want. We actually model the specific devices. And we do this and we give you instant access to rooted and jailbroken OSs because essentially, we have our core knowledge came from the jailbreaking community. And what we do is we can jailbreak the operating system before it ever even boots. And that allows us to do jailbreaks on any version of iOS, even up to the latest and greatest on the latest and greatest iPhone models, which is not something you're going to find in the public world. And we can do that because of our virtualization platform. And we don't have to rely on a public vulnerability or an exploit to do that jailbreak. Now, as you all know, Apple announced a couple of weeks ago that they're going to support iOS 17 only on the iPhone XS and higher. And what that does is closes the door for jailbreaking on iOS 17 on the devices where, for example, we used to be able to rely on the Checkmate boot ROM vulnerability that was in the chipset. That is an unpatchable vulnerability that we could use on any of the iPhone X and older devices that supported like iOS 15 and 16 to achieve a jailbreak. The problem is on 17, that jailbreak door is going to essentially be closed from that vulnerability. So we're appreciated. We appreciate the the furthering of the security research in our industry because of the fact that we're able to give you access to the devices at exactly the time that you actually need to use them in a jailbroken or rooted format. There's a question, someone's asked if it's being recorded. Absolutely, this webinar is being recorded. You'll be available shortly thereafter. Awesome. Okay, so before we switch over into our content, I do want to pop open one quick poll, and I'm going to launch this. Okay, so a little bit of engagement here. Let's make sure everybody's awake, everybody's got their coffee, everybody's happy and going this morning. Have you attended any Corellium webinars before? Or is this your first one? We've been doing talking about reverse engineering for quite some time, actually since last September, and there's a ton of content available for you to view on demand on our website if you are interested in watching some of those. So just give a few more seconds here for folks to come in and answer. All right, and we'll go ahead and share the results. So awesome. We've got a few people that have been following us for quite some time in this series. But we are very, very happy to welcome all of you who are, this is your very first webinar with Corellium. We really appreciate it. Again, this is like the culmination of everything that we've done for the past 6-7 months on pen testing mobile apps, both iOS and Android. So I do encourage you to please go check out that on-demand content. Stephen Smiley has done a fantastic job But now it's time to give him a little bit of a vacation after this one today. So with that, I am going to go ahead and pass it over to Stephen. And I will be here in the background answering questions. But again, I really appreciate everybody jumping on this morning, this afternoon. And go ahead, Stephen, and you and Rob can take the rest of the time all to yourselves.
Awesome. Thanks, Brian. I'm going to go ahead and share my screen here. Okay, perfect. So I'm not going to spend a ton of time here on this stuff because we've done similar intros in both the Android one or the other on-demand courses that you can see. So you can go out and take a look at some of that content. But just as a quick reminder about what is just kind of reverse engineering and what is being achieved. So reverse engineering is really just the process of breaking something down to understand how it works. So for mobile, that just involves deconstructing, analyzing, observing the compiled applications to understand the underlying functionality. There's too many types of people are working with. You got dynamic and static, just depending on what you want to do with the application. If you want to kind of manipulate it while it's running, have some various scripts, or if you want to do everything static, where you're just modifying the code, potentially repackaging the applications, or looking for hard-coded values. So essentially just what is being achieved. Well, there's a few different things. For one, you're going to gain a better understanding of the application along with its inner workings and everything it does. You could potentially find hard-coded values stored within the application, which we'll also take a look at quickly today. You can identify a path forward to exploit the mobile application and then just gain insight into the application to build additional scripts. Just looking at an application by default, launching an application, you're not really going to know what scripts to build, what to write in there, how to exploit that. You're going to need to do a little bit more. So part of reverse engineering is just understanding that full application to be able to build those scripts and exploit a little bit more. Okay, so the iOS file structure. So just quickly, if anybody has experience with iOS, they'll probably know a lot of this stuff. So we'll kind of skim over it fairly quickly. So you have the app bundle structure. So iOS apps are organized within a bundle. So you have a .app package, which then within contains various files and directories. Some of those key components are, the info.plist, which has a lot of configuration stuff. It's potentially hard-coded information in there, always good to look at. You have the executable, which is the binary that's actually running the app, which is a great starting point when you're into reverse engineering. You have the resources directory, which has assets like images and localized strings. Then you've got your frameworks and libraries, reusable code libraries. You have dynamic libraries, static libraries. Those are always good to look at as part of analysis. Probably not as important for the reverse engineering, depending on what you're trying to do. That executable is really kind of where you want to focus a lot of your time. You have your supporting files, your caches and temporary files, and then your document storage. All those are a lot of configuration stuff, various caches depending on how the app is configured, and local data. We did some webinar series on local data storage. So if you're interested in that stuff, go take a look at that. There's a lot of content on that, both in the blog and in the previous webinars around that document storage, caches, supporting files, things like that.
Hey, Stephen, we are getting quite a few questions in real quick, and you just kind of brought up the previous webinars that we've had. For those of you who are interested in seeing the previous webinars, if you go to Corellium.com/events and then click on the webinars tab, you'll be able to get access to all of those on demand webinars. So again, thank you for the questions. There's a couple of other questions coming in around, how do you get around fair play DRM and other things like that. We'll answer those offline and get back to you on that. But Stephen, we've talked a lot about those capabilities, and those are covered also in our previous webinars too. So if you want to check that out, feel free to do that. But we'll answer some of those questions offline for you.
Perfect. Thanks, Brian. And then there was just one on OS internals. I think we're going to start doing more content relating to that sort of stuff later months, but we haven't set anything hard up yet. So you'll see more information about that sort of stuff upcoming. So some tools for reverse engineering. There's a lot more. So if you're here for the Android one, there's not a lot of tools for Android. There's definitely a lot more for iOS. So we'll kind of go through these. So you got like Radare, which is an open source cross-platform disassembler and debugger with powerful analysis capabilities. It's ideal for deep code inspection, reverse engineering, very complicated tool. As you can see on the bottom as well, we do have R2 Frida, which combines that with Frida. Very complicated tool. Rob's going to go over kind of some stuff right today where we go over some of the commands and things like that, but a great opportunity for learning as you move into reverse engineering. We have things like Hopper, which is a disassembler, pretty popular disassembler for iOS. It's used for disassembling and analyzing executable files. Now the free version, I think, only allows you to do analysis for, I think, 30 minutes, 45. I think it's 30 minutes where it'll stop. You have to reopen the binary again and perform your analysis, or you can go with the paid version. There's Frida as well, which is a dynamic instrumentation framework. There is components of Frida, things like Frida Trace that can help you with reverse engineering, but really Frida, once you have the scripts from the other information you've gained, can be a good opportunity to exploit the application a little bit further. We have things like class dump, which is a utility that generates header files from the compiled iOS binaries. Just understand the app's class structure. It's a good starting point. There's a couple tools like that. Class dump, OTool, strings, they're really good starting points. All free. As long as you have like Xcode, they should all be installed already on your machines. You can use these to perform some intro analysis as you move into reverse engineering. Look for some various strings, look for some classes, some methods, whatever you need, just to get a better understanding of that iOS application. And then you have Ghidra, which is a reverse engineering suite, which was developed by the NSA. It's actually freely available. Seeing more and more people start to use that instead of things like Hopper or Ida Pro. So that's always a good option as well. Do we have more questions coming in? Sorry, I saw a couple.
Yep, we've got questions. Rob and I are answering them offline. If we have one that is
Sure.
that is awesome
Gotcha.
for everybody, we'll go ahead and answer that live.
No worries. So the Corellium Cafe app, if you guys were a part of other webinars, you probably heard us talk about it recently, but essentially the Corellium Cafe application is a fictitious coffee shop that allows people to purchase beverages. There's a bunch of vulnerabilities in it, specifically in this scenario. As we talk about reverse engineering, you have things like hard-coded values. There's various ways to kind of get those. You have root detection that can be bypassed either through a script or patching it out manually. So we're going to talk about that. And then there's additional functionality that can utilize reverse engineering to build out scripts, things like potentially exploiting web views, promo codes, things like that. Additional functionality. So there's some stuff we won't be able to get to, but just good to know for the future.
We do have one fantastic question, because now we're talking about Corellium Cafe again. And there's a lot of people asking, where can we get Corellium Cafe? We are very, very, very close to allowing everybody to have access to the Corellium Cafe. Right now, it is being used by Stephen and I and several others. Anybody who is currently doing an active trial of Corellium has access to the Corellium Cafe apps. We haven't decided yet or not whether we're going to make them fully publicly available. That decision is forthcoming, but at least if you're doing a trial of the Corellium platform, you are able to gain access to those applications through that free trial process. So the cafe apps are coming, especially now that we are kind of wrapping up a bunch of our content based upon Corellium Cafe. We have been very selective to give a few hints on where some of these vulnerabilities are and show how to exploit them. But we have not given all of that out in our webinars. So it's still going to be, there's still going to be some challenges in those applications for you. So stay tuned for the announcement of those coming out publicly soon. But again, if you start a free trial with Corellium, you'll have access to those.
Exactly. Perfect. So we got a couple practical exercises today. I'm gonna quickly go over, so the Corellium Cafe, we have a couple hard-coded secrets. So I'll quickly talk about that. I'm not gonna spend too much time on it because we do have a couple blog posts and previous webinars where we've kind of talked about this. The majority of the time we're gonna spend using R2 R2 Frida, and we're going to start patching out a binary and trying to bypass some of the security controls, which Rob will do. So with that, I just don't want to spend too much time. So I'll go ahead and we'll take a brief look here at some of these hard-coded secrets. So for one, this is the actual binary here. I hope everyone can actually see that. I can zoom in a little bit. So this is the actual binary itself. I have this cafe application. So as we kind of mentioned, there's a bunch of tools you can kind of do to start stuff, things like running strings. You could run strings against the cafe application. That's going to pull out every string, and then you could start, funneling those down depending on what you already know about the application. You can grep for things like maybe if you were looking for an email address or something, you could potentially look for like an @ symbol. That's going to be a little bit more difficult using strings. But there are a few things you can look for. You can look for like Corellium, just to see what's there. You see an email address there. So there's like one piece of information. And you start searching for various words. I know there's things like a promo code. So you could search for things like that. So you get some different classes and stuff that you need to kind of figure out. So alternatively, the other option is just kind of load this into some sort of tool like Hopper or Ghidra and start playing around. So not every application has these hard-coded secrets or things that can be easily gathered, but you can gain additional information about the application. And then Rob's going to show you some things like if you actually launch the application, maybe it crashes for some security controls. Maybe we need to bypass those first before we can actually take advantage of some of the stuff that, potentially we found. So it's just analyzing the app right here. So we're actually going to give it 1 second. But at least if you move it into like Hopper or Ghidra or something like that, you can do a little bit more advanced searches. Sorry, it's just freezing up right there just because it's analyzing. But if you do like @ and .com, you can actually find, if you didn't search for Corellium, you didn't find this email, you could potentially find it this way, where it searches for the @ symbol and .com. And it's going to find both. Or in the cases of like a promo code. So if you actually walk through the application, which I don't want to spend too much time on, but in the application itself, because you could purchase beverages, there is a promo code option so you can get a discount. So that's sort of the thing. If you don't know what that promo code is, if you think it could potentially be hard coded, it's something to go look for, or you need to figure out where it is in the application. You can start searching for that and then walking through the code and seeing it. So you see it's used here a bunch of times. If you actually walk through, this would take some manual analysis, but you have things like this where you actually look it up. And then if you just scroll around, you can see some different pieces of information. There is this code right here, which says Corellium is awesome. That actually happens to be the promo code that's actually hard coded. But again, this just takes some different analysis, right? There's other things you could do where you could actually look up different locations in this and try to hook different values and try to print them out using various Frida scripts. That's always an option. Or you can manually look through. So there's a couple of different options. That's really basic, but just a couple of different options. I wanted to leave some time because Rob's actually going to walk us through a little bit more on bypassing security controls and using things like R2 Frida. So I'm going to pass it over to him and let him kind of go ahead with what else we have.
Yeah, and while we're doing that, a question was asked like, do we offer virtual phone access like some of the other emulators or simulators that are out there? Yeah, you're going to see those in action here in just in a minute, where you actually get to see code running on a phone, or in some cases maybe code not running on a phone. So you'll see that here in just a few seconds. So just a quick intro to that. And do we allow debugging of syscalls? Yes, we actually have a feature called core trace, which allows you to create a trace log from every syscall made from an application gets traced into that log, and it provides wonderfully fantastic debug information for vulnerability exploitation, or even DevOps debugging, providing really detailed developer debug logs back to your coders. So those are a couple of cool features. I don't think Rob's going to show core trace today, but we are going to get to see everything else in action. So Rob, take it away, man.
Cool. Thank you, Brian. So hello, everyone. Thank you for joining. My name is Robert Ferri. I'm an independent consultant and researcher and also pen tester. And today I'm going to break down some reverse engineering techniques related to iOS applications, specifically this Cafe app. I'm going to be using this tool called R2 Frida, which is sort of, Stephen touched on it earlier. It's kind of a blend between Radare 2, which is a static reverse engineering framework disassembler, and Frida, which is everybody's favorites and probably one of the most well-known dynamic instrumentation tools out there. My goal for this talk is to show you that you don't actually have to be like a reverse engineering wizard or be able to read assembly at a really high level to figure out what's going on in the app and to do some basic reverse engineering. Specifically, I'm going to be centering this around jailbreak detection. I know there was a question about jailbreak detection earlier. I'm going to be, this is specific around jailbreak detection. I'm going to try and go over a couple techniques about some common techniques that they use for jailbreak detection and some bypasses that are also quite common and stuff that I use all the time when I'm doing mobile penetration tests. So let me share my screen. Let me make sure everything's set up here. Hold on one second, everyone. All right. Everyone can see my screen, I assume.
Yeah, I can see it. We're good.
Cool. All right. I'm actually going to bring up my slide. I have one slide, so everybody please just bear with me. It's not going to be as painful as it looks, okay? It's just that there's some, R2 Frida has some interesting commands that look daunting when you're looking at R2 Frida for the first time, or even Radare for the first time. But it actually makes a lot of sense when you really get into it. And I'm going to show that in a few minutes. So the first thing you need to do is you're going to need to download R2 Frida. The way you do that is, there's actually a couple ways. So one of its dependencies is Radare. So you can actually just go to the GitHub, and we have some links after for some of the things we're going to use. Radare 2 is its dependency. And you might think, like, well, what about Frida? Well, you probably already have Frida on your system in the first place, but actually R2 Frida comes with its own built-in Frida. It downloads it when it needs it. So, which is an interesting kind of quirk that I found out about it. So once you get Radare 2, it actually comes with this nifty package manager. This thing will go away from my screen. There's actually a package manager that it comes with, among other things. It comes with a few tools. This package manager right here, R2PM. This is probably the easiest way to get R2 Frida. You can see, you can do all sorts of things with this. You can actually search for, let's go Frida, right? And so to get R2 Frida, you're going to type in R2PM-CI, which is for clean install, and then you're going to type R2 Frida. I already have it, so I'm not going to do this. Give it a -L, you'll see what you have here. And so that's probably the easiest way to get it, and probably the best way. I think it's actually the one they recommend. You can also go to their GitHub and get it, which is pretty standard. Initial setup of R2 Frida, you're going to launch it by typing R2 space Frida : // This is to launch R2 with R2 Frida. And so we're going to give a question mark, actually, which will bring up the help pages. Sorry, yeah, where were we? We bring up the help pages. Okay, so there's a bunch of things that you can do with this. You can actually connect to locally on device. You can connect to processes and apps locally on your device. You can connect over USB, which is what we're going to be doing. You can also connect remotely if you need to connect over, say, like a LAN setting. And then there's some environment settings you can set. We're going to focus on USB since we're using this Corellium device over here. You can see we have an iPhone 12 Pro Max running 15.6, and it is indeed jailbroken. We have a little green check mark to tell us we're jailbroken. We also have Cydia running, which is a good indication that we're jailbroken. And if we launch the Cafe app, it's actually going to just crash. And so that's a very standard thing in the industry, where apps will launch and crash immediately if they're jailbroken. You see this a lot with banks, with gaming apps, things like that. Things they don't want you to reverse engineer easily. They'll just crash right away, and that's kind of a problem. It leaves you with a couple things. You can do you have to basically do a lot of static analysis to see what they're doing to get your hooks in properly. And so I'm going to show you a little bit of how to defeat that and how to see what they're doing without writing any JavaScript for Frida, and looking at very minimal and honestly very minimal assembly. We could actually just probably even skip assembly altogether. But in this case, I'm going to show you a little bit. So to launch the app with R2 Frida, we're already hooked up. I have this USB Flex tool. So if you're using Corellium, you need USB Flex. It basically acts as if this device is plugged in. So we're going to be using these USBs, and we can search for apps, we can search for processes, we can attach to a process by its PID, assuming it's running. In this case, it won't be because it crashes immediately. We can spawn apps and we can launch apps. So the difference here between spawning and launching, if you spawn an app, it's going to open the application and it's going to pause it. And so if we go with spawn USB, and we're actually going to type in Cafe because that's the name of the app, and we need to, right there, you're going to see it launch and it pauses. And then we're waiting. And now we're hooked up to R2 Frida. And so the difference is spawn will launch it and pause, and launch will actually spawn the app and continue the resuming. And we can actually resume manually by typing this command, :DC. And then if we want to launch the app just to show everybody what's going on, we can do Cafe, and it'll launch, and you'll see it's going to crash immediately because they're doing jailbreak detection. Thank you. Cool. So how do we deal with this? So initial setup, that's how you launch the app. One thing I should probably mention also is that how do you know what you're looking for? What are you connecting to here? So you can actually just type in spawn or launch or whatever, USB // and it'll list out everything that's on the device. It'll list out if they're running, you'll see a PID here. Nothing's running, so we don't see the PIDs. It'll give you the name and it'll give you the package identifier. And you can actually use any one of these to spawn an app on the device. And when you get set up, I'll show this in a minute. Or maybe I'll show it now. There's a special command in R2 Frida that's going to set up our environment for further analysis. And this is the :init. And so actually, if we go to Frida : / and type in a 0, 2, :/ and we type in a 0, it's actually going to launch in a special case where we can just play around. It's not really attached to anything, but it's good for demonstration purposes. So we can actually just play around if you want to see. So normally you would type in this :init, and it'll just run the thing. So if you want to actually see what it's doing, you can just omit the period and you can run it. And what's happening is it's setting up our environment. So it's setting a bunch of values. It's importing some things. And here, that's what these are doing with these stars, importing libraries, importing symbols and whatnot. and it's actually mounting the file system, which is a really cool thing with R2 Frida. It mounts the file system. I'm not going to go over this in depth today, but you can actually just start browsing the file system through R2 Frida, which is really neat. And the last thing it's going to do with this S entry 0 is it's going to seek to the entry point. This is the entry point of our application. It's called entry 0, which would be main. So what we're going to do here is I'm going to show some basic commands about what's going on, and then we're going to get into actually reversing and seeing what's happening with this app because it's crashing. So all the commands that you're going to see, or almost all of them, any that have to do with R2 Frida specifically, as opposed to R2, because you can use both with this tool. Any commands that are specific to R2 Frida start with this colon right here. And so a colon IC is going to list classes. And this is what I mean about how it's kind of unintuitive, but also at the same time, you're going to see that it makes a lot of sense. But you think IC lists classes, but if you think about it, the I, colon, if you do a colon I, it gives you information. So I think about as standing for information. Similarly, as I showed earlier, S is for seek. So if you need to seek to an address, you seek to entry 0. You use S. A is for analyze. So it seems daunting at first when you see the commands, but it's actually not that bad. You get used to it pretty quickly. So in this case, we have, I'm going to launch the app and I'm going to show you interactively. I'm going to spawn. I'm going to glance over something real quick, but I will come back to it later. I promise. This thing is in my way and I can't. How do I move this? There we go. I'm going to put this over. Sorry, technical difficulties with this thing. All right. So as you can see, we're spawned here. We are at 000. So we're going to run this init command. This is going to take a second because we are on, it's got a lot of things to import. And I think it's a little bit slower because we're not directly connected by USB. We just have this USB flux connection going on here. So while that's happening, I'll go over a few more things. You saw me earlier, I ran a question mark. This is one of the useful commands that's going on here. I'm actually going to go into this. No, I'm not going to go that. You saw this. So there's a question mark. This is probably the most useful command you can remember. If there's only one thing you take away from this slide, it's this question mark. This is going to help you in life. Okay. If you type a question mark at any point in R2 Frida or even R2, you'll see the help page for it. And it's going to be instrumental in picking you up and having you figure out what's going on. So you can just type the question mark in directly. If you do it in R2 Frida, you're going to see a list of commands for Radare itself. If you do a colon question mark, you'll see a list of commands for R2 Frida. And similarly, if you have a command like DTF, which is dynamic trace, one you're going to use extensively very shortly, and you do a question mark, you're going to see all the things that go into that. So it's going to show us a bunch of what's the word I'm looking for? Format specifiers. When you're tracing, there's a lot of format specifiers that you can have. So you can have, you can trace the arguments and you have to tell it what you want to see the arguments, like what format you want to see. Is it a string? Is it an object? So on and so forth. So that's probably the most useful command you can have. The next most useful one is this right here. There is this squiggly line called the tilde or tilde, depends on where you are, and the plus. And the tilde will do, basically, it is essentially grep. You can just think about the tilde as grep, and you can think of the plus as it makes everything case insensitive. So in the example here, we're importing exports from the application, and we're grepping case insensitive for the keyword jailbroken. And if this says run, we can actually show that. So we can actually show classes. If you do :IC, you're going to see a bunch of classes show up. There's 36,000. Yeah, sure. Let's show all of the classes here. There we go. And so we can actually just grep case insensitive. You know, I'm going to zoom in a slight bit more for everybody. We can actually grep case insensitive. And we're going to look for the keyword jail, and we'll see if anything shows up. And indeed, so here's a class called cafe.jailbreakChecker. You can look for other things. We got NS file managers, pretty generic. We got NS file manager here. So what we can actually do as well is give this IC, and we can pass in NS file manager, and that's going to show us all of the methods and the functions under NS file manager and where they live in memory. This is their actual address in memory, which is useful for when you're hooking. You can actually hook functions based on memory, or you can hook based on the path itself. And you can actually do this grepping later. So there's like 100 or something methods here. You can actually grep for specific things like file exists at path. So here's 4 things right here. We have file exists at path. We've got remove file at URL. We have file exists at path as directory. So you can use this, very powerful. So the 2 most powerful things you can remember is the question mark. Here's all your R2 commands and that tilde. And so you can actually do, there's colon question mark. These are the R2 Frida commands that you'll be needing. And I'm going to show you some of these very shortly. So DTF, I already went over, colon DTF. That's how we're going to trace functions. We're going to get into that more in depth very shortly. Same with this colon DI. This is actually how you replace values in R2 Frida, which I will also show you. These 2 come up a lot. S, we're going to seek to an address. AFR, I told you earlier. A's are for analyzing. AFR is analyze function recursively. And it's going to analyze the current function that you're at. So if you seek to a function and you want to see it, see what it's doing, see the assembly language, you're going to use AFR, and then you can run PD, colon PD, and if you give it a certain number, it will print out. P's are for print. It'll print out the next set of instructions. So if we do like a P20, you know what? We're going to seek somewhere actually. We're going to go here. Let's do this. We're going to look through the exports for Frida. So we have this one called detect Frida. This is where it lives. This is the function where it lives in memory. So we can actually seek with this S, and we can give it the memory address, and you'll see that we've actually changed to that memory address. And so we're going to go AFR. We're going to analyze this. And so we can do this PD, which, again, if we do disassemble, you can do a question mark, and we can tell it to disassemble 20 instructions. And we've done it now. We've broken it. Technical difficulties. Sorry, bear with me. Let me crash this guy. Come back to us. My bastard. There we go. Process terminated. Okay. One command I don't have in here is this OO. These are small case, lowercase O's. These are not zeros. This will actually just reboot the process, which is really nice. So we can reboot the process. And I don't know if we're here, but let's do PD. Yeah, well, we're here, but now we're kind of, so we can seek back to entry 0. Sorry, let's look for that again, see where it is. I'm gonna run a init again. Okay, so we're gonna try this again. But essentially you can do a PD and you can give it, say, 10, and it will print out 10 instructions. You can also do it as PDF, which will print just the entire function. And of course, I already spoke about DC, which will continue execution later, which is going to become useful. You'll see in a few minutes. A couple other useful things. I've already mentioned the question mark and the tilde. You can actually import Frida scripts. If you already have a script set up, you can actually import it with a colon period, and then just pass in the script where it lives on your system, and it'll bring in the script and it'll run it. We're going to be using this one later. It's a period, and we're going to use this .r2 file, which is essentially just like a configure. You can think of it as a configuration file. You can just type out commands in this .r2 file that are line delimited, and when you import that, it will automatically, like if you have traces and hooks and stuff in there, it'll automatically import them and run it. And if this comes back online, I can start showing some stuff again. There we go. We're back. We're back, baby. Let's go. All right. So we're going to seek back to this file. We're going to add var so we can analyze, and the function is broken. Oh, it's still working. There we go. Invalid function. Awesome. So I just typed a PDF. This is an R2 command. This is not an R2 Frida command. I accidentally, I guess I put that in the slide. There's no colon in front of here. So this is R2 that's actually doing the reverse engineering. What's really neat is that this is actually live on the device. We haven't loaded the binary. I actually have R2 set up. I've loaded the binary in here statically, but this is actually on the device. So we can do some cool things. We can actually just change values. We can change opcodes and stuff like that. We can mop out instructions if we want to, which I'm going to show you in a second. So this is the actual detect Frida. And what usually happens when you launch a device is they're detecting Frida is one of their jailbreaks, and they do this in a few ways. They generally will set up a socket, and they'll use like the listen function or the bind function or something similar to that nature to listen if connect to the socket if Frida is listening. Frida listens by default on localhost port 27042. And for those who know anything about hex, right here, 6982, this is hex for that. 27042. You can actually just go get hex to decimal converter. And we can just type that in there, 27042. So we have some idea of what this app is doing. It looks like it's detecting Frida. So the easiest way to defeat this is just start the Frida server on a different port, right? Sometimes the easiest way is the best way, okay? I'm not gonna do that because that's not a lot of fun right now. That's just one of the ways to do it. If you're gonna, be reverse engineering stuff, put Frida on a different port, and all of a sudden they won't be able to detect it. And that easily defeats one of the checks that's going on. Another check we're gonna do, so what we're actually gonna do is we're gonna set up this file and we're gonna run it. And this file is going to have, we're gonna trace a few functions, and eventually we're gonna replace values, and you'll see that we'll bypass these checks that are going on here. So we're actually going to, and I'm going to get into the trace command in a second, and I'm going to show you how you can figure out what's going on so you can actually set up your own traces.
Just to note, Rob, you have like 8 minutes left, roughly.
8 minutes left. Okay. Okay. Cool. We're going to do this real quick then. All right, so the first thing we're going to do is we're going to look for, we're going to set up this file, and we're going to look for certain commands. I already mentioned bind is very common, and we can actually just pass it ATF bind. We're going to look for Objective-C ns file manager dot file exists at path. And we're actually going to pass it some specifiers, which I'm going to go over if I have a second. I actually need to go over those. And you know what? We're going to stop there. We're just going to do those two for now. So we're going to save this file. And so if we give this DTF and give a question mark, we're going to see these are some format specifiers you can pass to it. And I'm going to show you right now. So right here, we're hooking an Objective-C function. And Objective-C function, the first two arguments to it are a memory address and the selector, which is the actual function name. So that's why I'm using X for a memory address. We're just going to show it in hexadecimal so it doesn't look all funny. And we're going to use Z, lowercase z. It's going to show us the string. It's going to show us file exists at path. And then the actual first argument and the only one for file exists at path is an object. And I'm going to show you that right now. You can actually go into file exists at path. I'm going to screen this. So if you look at the Apple documentation for file exists at path, it explains everything that's going on. So it returns a Boolean that indicates whether a file exists at a specified path. You can see it's an Objective-C function just based on how it looks. It returns a Boolean here and it takes an NS string. So if you actually click on NS string, you'll see that NS string is an object, which is why we're passing a capital O in this case for the specifier. And if you scroll up, if you're at the actual documentation, you can scroll up to the next step out right here, which is NS file manager. And this is the class that loads file exists at path. And so that's how you know what to load. That's how you know what specifiers to give it. And that's for Objective-C functions. For native functions, you can just pass. It depends on what you're looking at. It's say if you're looking for ptrace, you can actually pass it. I think I have ptrace up right here. Ptrace takes four what are essentially ints, and so you would just pass ptrace and then give it 4 i's as a specifier, and you'll see what's going on. If I have a second, I can get into ptrace in a moment. But so we've loaded this. We've got our file set. So we're gonna look for bind, and we're gonna look for file exists at path. These are two very common things that are going on here. And our app is running, and we're gonna continue execution and see what happens. So we're gonna use this DC, and it terminates. And you know what I didn't do? Oh, please, technical difficulties. I need to import this. And so with this dot command, unable to contain. Okay, sorry. Why don't we seek back to entry? I don't. Sorry, guys. Technical difficulties. I'm running it again. It's been a little funky lately. R2 Frida. It's usually not this crazy. I guess I have 4 minutes left. So once that boots up again, I'm going to show you really quickly what's going on. But this gives me time to talk about a few other things. So there's this, I mentioned ptrace earlier. Ptrace on iOS is what's called a private API. You're not actually allowed to use it per the Apple spec. And so if you try and just look for ptrace, if you try and just build an app and call ptrace directly, when you go and upload your file to Apple to try and get it on the App Store, they'll deny you because it's private. You're not supposed to use it. What ptrace does, it's for process debugging. Generally in jailbreak protection, they'll be using this ptrace deny attach, which is just going to tell the app to not allow a debugger to attach. And if there's one attached, just to boot it out. And you'll see with ptrace, this first int will be a 31. That's what you're looking for when you hook ptrace. You want to see if this is a 31. If it is, you can change it to 0. You can return 0, whatever you want to do at that point. As I mentioned that it's a private API, so you can't actually call it. So one way they call it is with this DLSIM. DLSIM essentially will resolve an address that they can then later use. These developers can later use to call that that function. So ptrace. So they'll use DLSIM, and you'll see this second one here takes a symbol. This argument would say ptrace, or it'll say whatever else they're trying to do. Sometimes they even resolve DLSIM themselves to be a little more shady about what's going on and a little more obfuscated. It just makes it kind of harder to figure out from our perspective as a reverse engineer what's going on. So that's ptrace in a nutshell. I wish I could spend more time, but I'm running out. So where are we? So we're loading our file. Access denied. Oh, it's already here. All right, cool. Uh-oh. The demo gods. It's real. All right. We're gonna do this the easy way. Normally that would just run. So we'll do this manually. Then we'll hook bind. Hook bind, and you'll see it returns true. And we're actually just gonna run the command. And you can see that, so it'll give you the args and it'll give you the red val. The red val is what we're concerned about. With bind, it'll return a -1, which is all these Fs. If it failed, or it'll return a 0 if it doesn't fail. So we actually know that they're using bind in some way. And so we can use the di command. And if you use di0, it'll tell the function that you're hooking to return a 0, which is going to say that it succeeded, and it's going to pass our test. And you can see it didn't crash the app. It just went straight into it, which is nice. So sorry, we have 1 minute left. Can we go over at all, Stephen? A couple minutes?
Yeah, you can go over just a little bit. Yeah.
Okay, I'll hurry it up. We'll go over just a couple minutes. I'm not even going to bother with the file at this point because I don't know why it's giving me trouble. But essentially, what's going on here now is there's a hard-coded value in here. Core admin at corellium.com, and we're going to pass in I actually need to go back here. And we're going to log in. And you can see it tells us that we passed jailbreak detection, but we actually haven't. You can see there's a bunch of sus files that show up. And what's going to happen is it's just going to close the app, because that's what happens when you do jailbreak detection. Your app gets closed for fun. So we're going to relaunch this. Corellium freeze. All right. Okay. My Corellium device is frozen. Let's do this. Kill 1. Will you respawn? Spawn already in progress. That's not great. Something else. So, okay. Well, that's a shame. The device is frozen, guys. If I have to reboot it, it's going to take too long.
Yeah, that's okay. Is there anything else you wanted to
Yeah,
let anybody
I
know
was.
prior to?
Yeah, I'm sorry, guys. That demo god thing, I guess what's going on
we
here.
didn't sacrifice enough to the demo gods today.
That's so
So let's do
unfortunate.
this, Rob.
Yeah,
We're going to go ahead and thank everybody for their time. We'll post a follow-up blog with a demo video shortly
Okay.
on our website as a blog. So, thank you everybody very, very much for your time today. Went over a couple of minutes, but not too bad. Rob, thank you very much for your time today and your efforts. Stephen, as always, thank you as well. And again, we appreciate everybody hanging out today. We will send the recording of this out shortly. For those of you who have questions in there, we will also get back to you offline with those questions. So thank you all very much and have a fantastic rest of your day.